The scientist of my choice was J. Robert Oppenheimer. His birthday was the 4th of April of 1904, thus making his polynomial equation f of x equals negative 4x to the power of 5 plus 2x to the power of 4 plus 2x to the power of 3 plus 9x plus 4. Now, J. Robert Oppenheimer was a considerable piece of work. Although his accomplishments were massive and earned him high-rank places, it would be thought morally questionable. He was a theoretical physicist and had been a physics professor at Berkeley. From 1943 to 1945, he was the leading wartime director of the Los Alamos Laboratory in New Mexico, and through his work received the title Father of the Atomic Bomb. During World War II was when his work picked up in New Mexico on the Manhattan Project. However, after the war, he would also direct the Institute for Advanced Study in New Jersey. He had died February 18, 1967. What I thought my equation's graph would be related to would be the atom. Specifically, with a quote like, "I am become death, the destroyer of worlds," I related the graph with the line going through the atom that such devices such as the Fat Man, or even the little boy, made possible. Of course, I don't think weapons of mass destruction are things to be idolized. For my equation, I discovered that the degree would be 5, and the leading coefficient would be negative 4. The y-intercept would also be 4, and all of the real number zeros, x equals negative 1, x equals negative 0.466, and x equals 1.604, I found negative 1 through synthetic division, then tested all the possible zeros of the second product, 4x to the power of 4 minus 6x to the power of 3 plus 4x to the power of 2 minus 5x minus 4, and discovered none had worked. Afterwards, I had plugged the equation into a graphing calculator to find x equals negative 0.466 and x equals 1.604, as well as confirming my first discovered answer. To find the local turning points with a table of values, you plug in the x values around each turning point and observe where the y-coordinate increases or decreases. Find where the y-coordinate begins to increase/decrease, and repeat for each turning point. My polynomial function only had 2 turning points, those of which being negative 0.778, negative 1.466, as well as 1.097, 14.258. The end behavior of my polynomial function would be this. As x approaches negative infinity, f of x approaches positive infinity. And as x approaches positive infinity, f of x approaches negative infinity. The end behavior from my polynomial function would be this. As x approaches negative infinity, f of x approaches positive infinity. And as x approaches positive infinity, f of x approaches negative infinity. To find out how many zeros and turning points my graph could theoretically have, I used Descartes' rule of signs, in which the number of changes in sign between the terms of the polynomial are equal to the possible amount of positive real zeros. In order to find the negative real zeros, you find the changes in signs between the terms in f of negative x. Because f of x has one change in sign, there is only one possible positive real zero. F of x has 4 changes in sign. Therefore, there were 4 possible negative real zeros. The relationship between the degree and the end behavior of a function is that, depending whether the degree is even or odd, the end behaviors both approach the same value or differing values. For my function, because the degree is odd, f of x approaches infinity while x approaches negative infinity, as well as f of x approaches negative infinity while x approaches infinity. This is the graph with all the points labeled. The table shows all the numbers colored if you can't directly see on the graph, with blue being the zeros, purple being the y-intercept, and orange being the turning points. And though this may not be the most perfect representation of an atom, you shouldn't go around splitting them either way. Thank you for your time.